Okay, we are on 22D, where we are just applying what we learned in 22A and 22C. So I'm just going to go through a couple of questions that apply what we learned, e to the x, natural logarithm of x, with arguments that might not be simple. So what we are going to do first is we are going to find the equation of the tangent to y equals e to the negative x at the point where x equals negative 1. The first thing I'm going to do is I'm going to figure out what the y coordinate is of that point. I know the x coordinate is 1. So the y coordinate is going to be e to the negative 1, which would be 1 over e. All right? So that's my point. Then what I'm going to do to figure out the slope of the tangent line at that point, I'm going to find the derivative. So y prime is going to equal the derivative of e to the negative x. So the first thing I do is I take the derivative of e to the something, which is e to the something, and I multiply by the derivative of that something, and the derivative of negative x is negative 1. So if I plug in 1 in for x, then I have that y prime at that point is e to the negative 1 times negative 1, which can be written more simply as negative 1 over e. All right, so my tangent line is y minus y1, which is my 1 over e from up here, equals the slope, which is negative 1 over e, times x minus x1, which is just 1. And you can simplify that if you want to, and you can make it look all pretty and nice in slope-intercept form, but I'll leave that up to you to do. The next example we're going to do, we're going to find the equation of the tangent, and actually let's change it up. Let's make it the normal this time. We've already done tangent in the last example, so let's make this the normal. So we're going to find the equation of the normal to this curve at the point where y is negative 1. Well, now I've got a y coordinate, so I've got to figure out what my x is. So I'm just using regular algebra here. So y equals the natural log, negative 1 equals the natural log of root x. So how do I get rid of that? I raise both things as an exponent of e. So I get e to the negative 1, which is 1 over e, equals e to the natural log of root x. Well, e and natural log cancel each other out, so I'm just left with root x. And so to get x, I will have to square it, which means I'll have to square this. So x is equal to 1 squared, which is 1, over e squared, which is e squared. So note, all I've done here is I've just figured out the x coordinate of this point. Okay, I've done nothing more than that. So I know that this curve and the normal line will pass through 1 over e squared and negative 1. Now it's time for me to take the derivative so that I can get the slope. So I take the derivative of this. Y prime is the derivative of the natural log is 1 over something. I'm doing that. And the derivative of x to the 1/2 is 1/2 times x to the negative 1/2. Well, this I'm going to make it look a little nicer, because I think I'm going to get something pretty special when I do that. 1 over root x is 1 over root x, and when I simplify this, this is 1 over 2, and then I can bring this x to the negative 1/2 to the denominator. That will make the exponent positive, and so it'll be x to the positive 1/2 on the bottom, which is just root x on the bottom. This can be multiplied out so that it is 1 over 2x. All right? So that's, in general, what the slope of the tangent line will be, which means that the slope of the normal line will be the negative reciprocal of that, which will be negative 2x over 1. So in my case, if I'm looking at the point 1 over e squared, comma negative 1, the slope of the normal at that point is going to be negative 2 over e squared. All right, so now I have a point, x and y. I have a slope, which is right there, and I can write the equation of my line. Y minus that, so y minus negative 1, which is y plus 1, equals the slope, negative 2 over e squared, times x minus x1, and my x1 is right here, 1 over e squared. And just like before, you can pretty that up, make it look like it's in slope-intercept form or whatever, but I'll leave you to do that. And those are two examples of the kind of stuff that we're going to be doing in class tomorrow. So email me any questions you have, any concerns, and then we will work on this as a class tomorrow.